Hello everyone. In continuation with the Thinking Machine series, I would like to introduce another point of view for building thinking machines. You should look at my earlier video series to get better context and continuity, which will help you get into learning groove. I am not just going to talk about the next step in artificial intelligence. I am going to lay out the blueprint for an entirely new kingdom of computation. We stand at a pivotal moment in history, moving beyond simply creating better algorithms to architecting machines that can genuinely think. The genesis of thinking machines, a practical, though ambitious, blueprint for how we can combine the strengths of AI, the profound power of quantum computing, and the incredible efficiency of neuromorphic hardware to unlock a new era of cognition. Before we build the future, we must understand the limitations of the present. We've hit a wall. The very architecture that powered the digital revolution for 80 years is now our primary bottleneck. The energy required to train our most advanced AIs is staggering. The constant shuttling of data between processor and memory wastes 90% of our energy. And most critically, there is a class of problems vital for scientific discovery and advanced AI that classical computers will never be able to solve. To move forward, we don't just need a faster horse. We need an entirely new kind of engine. The solution is not to pick a winner, but to orchestrate a synergy. We envision a thinking machine built upon a trinity of computation. At the top, advanced AI algorithms act as a cognitive orchestrator, the executive function. The foundation is a neuromorphic fabric, a bio-inspired architecture that provides unprecedented energy efficiency and the ability to learn from the real world in real time. And for the problems that are simply impossible for classical or neuromorphic systems, a quantum core provides the deep computational power. Together, they form a cohesive, powerful, and efficient whole. Let's look at the first pillar, neuromorphic computing. This is a fundamental reimagining of hardware. Instead of processing everything all the time, chips like Intel's Louis II or IBM's North Pole process information as discrete events or spikes. This is incredibly efficient. More importantly, they fuse memory and processing. The synapses on the chip both store the state of the network and compute, completely eliminating the data transfer bottleneck. This allows the hardware itself to learn and adapt on the fly, much like a biological brain. In our hybrid system, the neuromorphic fabric acts as the machine's cerebellum and sensory cortex. Its job is to sit at the edge, interfacing directly with the chaotic, analog real world. It can process video, sound, and touch with phenomenal efficiency, recognizing patterns and learning continuously. Think of it as the system's reflexes and senses, providing a constant, low-power awareness and an adaptive foundation for high-level thought. Next, the quantum core. It's crucial to understand that quantum computers are not just faster, they compute in a fundamentally different way. By harnessing principles like superposition and entanglement, a quantum processor can navigate a solution space of astronomical size in a single operation. It's like being able to check every path in a maze simultaneously. This doesn't make it good for sending email, but it makes it an unparalleled engine for solving certain classes of problems, specifically optimization and simulation, that are the bedrock of science and advanced AI. Within our thinking machine, the QPU acts as a prefrontal cortex, reserved for tasks of deep, abstract cognition. When the AI needs to train a new, massive model, it won't spend weeks on thousands of GPUs. It will pass the optimization problem to the quantum core. When it needs to invent a new drug, the quantum core will simulate the molecular interactions. It provides the machine with the ability to perform computational feats that are, and always will be, out of reach for classical hardware, enabling true creativity and discovery. Finally, what holds this all together? The AI itself, but not as a simple application. The AI orchestrator is the system's thalamus, the central relay station, and its executive function. It's a meta-learning agent that understands the strengths and weaknesses of its own underlying hardware. It intelligently decomposes problems and manages the incredibly complex task of translating information between the three distinct computational domains. It is the consciousness of the machine, directing resources and unifying the system's capabilities towards a single goal. So, how do we physically build this? It's a monumental engineering challenge. At the bottom, we have the quantum core in its cryogenic refrigerator. The key breakthrough, which we are seeing in labs today, is the cryo-CMOS interface that can operate at ultra-low temperatures to bridge the quantum classical divide. From there, photonic interconnects, transmitting data as light, provide a high-bandwidth, low-energy communication channel to the room-temperature classical hardware running the AI orchestrator and the neuromorphic fabric. This is the physical blueprint. Hardware is nothing without software. To make this machine usable, we need a new software stack. At the bottom, a hardware abstraction layer provides basic control over the exotic hardware. The magic happens in the middle layer, the hybrid compiler, which is a software embodiment of our AI orchestrator. It takes a high-level command and intelligently compiles it for the hybrid system. At the top, application frameworks will allow developers to leverage this incredible power with commands as simple as model.quantum optimize, hiding the immense complexity underneath. Beyond that, we enter the realm of true creativity. This machine wouldn't just solve problems we give it. It could generate novel ideas and hypotheses on its own. And on a more philosophical note, this architecture provides a fascinating parallel to modern neuroscientific theories of consciousness, like integrated information theory. These theories propose that consciousness arises from the brain's ability to form a single, highly integrated experience from countless parallel inputs. This machine, by its very design, is built to do just that. It's a speculative horizon, but for the first time, we have a potential architectural path. Let me be clear, we will not be building this machine tomorrow. This is a grand challenge on par with the Apollo program or the Human Genome Project. There are immense hurdles in hardware, software, and fundamental algorithm design. But the work has already begun. The pioneers, from large corporations to agile startups, are laying the track. The qubit counts are rising, the neuromorphic chips are becoming more powerful, and the first hybrid algorithms are being tested today. The road is long, but for the first time, we have a clear map of where we are going. I am now happy to take any questions and comments. I will further share the more insights and details about how to build thinking machines and underlying principles in my coming video series. Please subscribe my channel and like the video so that I can bring interesting insights and updates on thinking machines.